What's up, guys? Just getting everything set up. What's up, Roy? Can you hear me, Roy? Be my tester. And can you see the screen? Just want to make sure we're all good there. Yes to both. Awesome. Thank you. It is hot today in San Diego. I am sweaty. Very, very sweaty. And I was just cooking. LA, yeah, I bet. Yeah, I was cooking in our small kitchen. So that just made it even hotter. Had the oven going, had the stovetop going, had the air fryer going. It was burning me up. Hey, so I'm outside. I'm recording this outside. And can you guys see me, by the way, as well? Can you see me and the screen? Yes. Okay, great. All right, so I give people about a couple minutes after 7, and then we're gonna get going on E6B stuff. We're gonna do a bunch of examples, talk about the computation side of the E6B. We probably won't get to the wind side, but if you guys want, we can do that next week. The wind side, I don't mind that. I just think there's plenty to get to. Can you guys hear that airplane right now? Is that really annoying, or can you hear my voice over that airplane? All good, cool. All right, thank you guys.
Recording in progress.
Whoa. Awesome. Yeah, I live very close to San Diego International Airport, so they planes are pretty loud. But what's really cool is about 2 minutes after a plane passes by, you can hear the wind go like, and that's the wingtip vortices from these big jets. And you can see like the palm trees nearby and stuff. They'll move like it's like clockwork, like every like minute after they pass. So it's just like, it's cool to see what we learn in action, you know, and how the wingtip vortices from these big jets, they trail the jet and then they descend downwards. And so you can just see that right from our little balcony, which is cool. Yep, the wake turbulence, yep. Yeah, it's hard to get on video. I'm gonna try to get it on video though. There's a place, if I go a couple blocks over, it's like really loud. And so I should do that. Even just like a little voice recording to hear what it sounds like. It's pretty cool. I was talking to a guy, I was playing golf with a guy, and he said that he lived in this area too, and that he was doing something where it wasn't windy out, and he lives in like a neighborhood, so there's not a lot of wind that gets through there, but between the buildings. But he was setting up like a bunch of these like flyers or something on this table, and like every 10 minutes they would blow away, and it took him like all day to figure out that it was the airplanes. So yeah, not sure. So last week I did some of these live lessons I share to everybody. Like I share to people on my Instagram, you know, people on my email list that have like subscribed but aren't in the ground school. And but this one is just most of them will just be you guys in the ground school. Keep it, you know, intimate, and so your guys' questions can get answered, you know, the paying customers, all that stuff. So that's what we have today. So we might not have a ton of participants, and that's okay, as long as there's a couple of you guys. Even if there's just one of you guys, I'm here to teach. So like I said, we'll give it 2 more minutes. We'll start at 7:02. I kind of like that time. Where is everybody? So Fedor, is that how you say it? Is in LA. Roy, you're in Florida now, right? Where? Miami. Miami's beautiful. I love Miami. Where's everybody else chiming in from? I forget. Robert in PA, Pennsylvania. Keith, that's right, Huntsville, Rocket City, or whatever. Just moved from Hershey, Pennsylvania. Is that what? That's where the like Hershey chocolate factory is, or am I being stupid? Okay. Man, I love this Zoom. It's so much faster than the Facebook. Like there's not really as much of a lag. That's great. All right, so give it 1 more minute. Roy, I assume the Hershey brand was named after the town, not the other way around, right? It was a guy. Oh. So did he start the town? Like they built a big factory and employed people and all that stuff or something? All right, so I think that's good time to start. Let me close out of a few things. Oh, that's nice. Cool. All right, so let's do this. Let's get started. What's up, guys? If you see beads of sweat coming off of me, apologize for that, but it's hot here in Southern California. Today we're going to talk about the E6B. We're going to do a bunch of examples. And like I said to some of you guys, it's just a small group today, which I'm totally fine with. Some of these I will share, you know, if I think it's a really common question, like what questions do we need on the FA, what equations do we need on the FAA written, like last week, I'll share it to kind of everybody, even, you know, prospective students of ours. But most of them are just going to be for you guys. That way you guys can be sure to get your questions answered. And then one really cool announcement is I released a podcast today. So the first episode is up. I'm going to be releasing that to the public once a week. But as soon as I figure out how to get it into probably your bonus course, I will put like all of them there for you guys. That way you guys kind of get like first access. I just got to figure out how I'm going to do that. But right now I have 5 of them done. So I want you guys to have instant access to those so you can, you know, I want to try and do kind of make 5 at a time and be ahead of schedule, you know, fingers crossed on that. But anyways, that way you guys can listen to those before everybody else. But all right, so, and if you haven't checked that out, it's on Apple Podcasts, Spotify, Amazon, and soon to be Google. I didn't even know Google had a podcast thing, but they do. So check it out. Let me know what you think. And like I said, yeah, you'll be able to get access to a lot more of them coming up. All right, so let's get started. All right, so and let me know, just put in the comments if the screen goes out or you can't hear me anymore or anything like that. But so here we have the E6B. This is the kind of flight computer side, and then we have the wind side. So I'm gonna just talk about kind of what these things are, kind of the general features of this. The E6B is great because you can take it on your FAA written exam. And hold on, I just want to make sure I'm recording. Okay, yes, I'm recording. All right. So the great thing is you can take it on your FAA written exam. You can have it on your check ride, you know, your check ride oral. What's great about it is that it has everything you need on it. It tells you sort of how to do an altitude correction. It tells you how to do airspeed correction. It tells you how to do, you know, get a miles per hour or ground speed with distance and time. And then also a fuel consumption rate and distance and time, or sorry, and gallons in time. So fuel used in time. So if you just kind of know how to use these, what these mean, you don't really have to remember much. And then it also has a temperature conversion scale down here. This has nothing to do with the wheel moving. So this wheel spins around and this temperature scale doesn't spin. So this is just straight up like 10 degrees Celsius. Celsius is up here on the top. And then Fahrenheit is down here on this bottom scale. So if you have 10 degrees Celsius, you just look right here at 10 degrees, and that's about 50 degrees on this scale, Fahrenheit. So that's all it is. But let's get to some examples because that's the best way to learn. And then I'll tell you kind of what these mean and how to do those examples. And I'm going to be using this really cool, handy dandy E6B Flight Simulator. And this is the University of North Dakota makes this. And it's really cool because you can spin it around on your computer. I've talked about this before, but and it also has the wind side, which I mentioned we probably won't get to today, but we'll probably do that next week because there's a lot to cover on this side. But I'm going to send you guys that link in the chat to this. It's a really handy tool. I used it so much when I was a student. So we're going to be using this, and we'll. Can you guys see this, by the way? Let me know if you can't see this, but we'll be jumping back and forth to this, and we'll be doing these different examples. All right, so first one, right up here, we have how far have you traveled in 2.5 hours at a ground speed of 133 knots? Okay, so we have 2.5 hours. So we have a time and we have a ground speed. So, oops. So here in this, we're going to be using this. That's the same thing as this equation right here. So we have ground speed and we have time. So we need distance, and distance is going to be on the outer scale. So what that means is we have different scales that's, go in a circle around this. We have this inner scale that's the darker gray that spins. And then we have the outer scale that's the lighter gray out here that does not spin. So inner scale, outer scale. So the outer scale, it says is distance. So it says that it tells us to set, and let me just check the chat, make sure everything's good. Okay. So it says to set miles per hour over this thing, this triangle. Okay, so here's the triangle. So we put the miles per hour over the triangle, and then we should have distance on the outside scale over our time. So we know time, so we just look for time on the inner scale and then read wherever time lines up, we read the distance on the outer scale. So let's do that with 2.5 hours at 133 knots. So the first thing we're going to do is set miles per hour over the triangle. So here's our triangle, and our miles per hour is 133 knots. So here's the next thing you kind of got to know. This outer scale, it goes from 60, 70, 80, 90 to 10. So what the heck? Why does it go to 10? Where is 133? So what you do is, and the reason they do this is they know that ground speed is usually going to be somewhere between, these values. It's likely not going to be lower than 45, but if it was, you could come down here and use the really slow speeds. But what you kind of have to do is kind of have to use common sense. And so what would be after 90? That would be 100. So this 10 can represent 10 or 100. So it goes 100. So you just add a 0. So 100, 110, 112, or sorry, 110, 120, 130, 140. So when we're looking for 133, it's going to be right after this 13, and it's going to be 3 notches after it, because each notch is a knot. So we line up this triangle with the 3rd notch after 13. And we had a student, Mark, in our group talk about this week how the errors that you can have with this flight computer. And it's very true, especially when you're starting off. When you make a very small mistake, right? Let's say you go after, the 3rd one after this notch. So you put it here. It's going to change your answer quite a bit. So you have to be really careful and make sure that you are doing it exactly right. And the cool thing about this tool is you can zoom in like this. You can count 1, 2, 3, and then you can zoom out. And I'm just doing control and then spinning the thing on my mouse. So once that's lined up, it tells us that we can read distance on the outer scale over our time on the inner scale. So time is 2.5 hours. So let's find 2.5 hours on this inner scale. So if you can see, there's kind of 2 scales in the dark gray. There's 30, 35, 40, 45, and then there's 5 that looks like 5 o'clock, 6 o'clock, 7 o'clock. So what this innermost scale is hours. So we have 4.5 hours. This is that 4:30, 5 hours, 6 hours, 7 hours. Right here's an hour and 10 minutes. And if you look, it correlates to the minutes. So an hour and 10 minutes lines up with 70, that's 70 minutes. Hour and 20 minutes, that lines up with 80, that's 80 minutes, and so on. So the minutes are kind of, and where does it say that? It says These labels can get kind of confusing, but it says somewhere on here that it's minutes. Anyways. So what we want to do is we want to either find the minutes or the hours. We know it's 2.5 hours. So let's look for 2:30. Oops. Okay, so 2:30. So this is lined up. We don't want to move it. It's lined up on our ground speed. We look for 2:30. 2:30 is right here. So then we read off. So 2:30 lines up with 15. You add a 0 to that. That's 150. 150 minutes. Okay, is 2.5 hours. Okay, and then we read on the outer scale. It's kind of hard to see because we're upside down, but we have 30 here. So 31, 32, 33, about 33.5. We're about halfway between 33 and 34. So 33.5. Or does that make sense? No, it doesn't, because it's not 33.5. It's actually 335. And again, that's kind of what I was saying. Kind of have to go back to common sense and say, okay, if I'm traveling for 2.5 hours, so 2.5 hours at a ground speed of 133 knots, does it make sense that I traveled 33 nautical miles in 2.5 hours? No, because that would mean you're going like 10 miles per hour or 15 miles per hour or something like that. So that doesn't make sense. So that's when you say, okay, I'm going to add a 0. So you get, so this is 300. That's 310, 320, 330. So it's between 330 and 340. So about 335. So we go back, and I see that someone is on the chat. Just let me finish this and then I'll check the chat for you guys. So we go back, and this is why I like to memorize these equations. And the nice thing is it's on here. It says miles per hour equals distance over time. So we want to know distance. So if we rearrange this equation, distance equals, by multiplying time to both sides, is ground speed times time. So if we multiply 2.5 hours by 133, we're going to get about 335. That's another way to kind of to make sure you're not going insane. You're on the right track, right? So if you're like, oh, is that 33 or is it 300? That's where these equations come in handy, and make sure that, you know, these E6B flight computers. That's why I'm just more of a math guy, but it's up to you. Either way, you just kind of have to use common sense for these scales, because they can mean multiple things. They can mean 330 or they can mean 33, depending on what you're calculating. Okay. All right, so hopefully that made sense. Let's move on to the next one. So let's do this next yellow one right here. How fast are you traveling if you travel 95 nautical miles an hour? Or sorry, not nautical miles in 45 minutes. So this time we're wanting a ground speed. So we're wanting this. And we have distance over time and time. We have 95 nautical miles for distance, and we have 45 minutes for time. So instead of putting this triangle on our ground speed, because we don't know our ground speed, we're going to put our distance and match it up over our time on the inner scale. And then we read off our ground speed over the triangle. So right now that would be 60, but we're not lined up yet. So that's all this is doing. It's either, there's 4 things here, right? There's this triangle, there's a ground speed on the outer scale, there's a distance on the outer scale, and there's a time on the outer scale. You know one of them at all times. You know this triangle. And the problems are always going to give you 2 of them. So when you know 3 out of the 4, you can find the 4th one. Okay? Because when you know 2, you can line it up, and then you know this triangles, and then, or you know both these, and then you know one of these, and you can line it up and read it off. So that's all it's doing. So let's go do that. So we have 95 nautical miles in 45 minutes. 45 minutes is also the same thing as 0.75 hours. So Just remember that. All right, so we want to match up again, distance of 95 nautical miles on the outer scale, this scale, and time of 45 minutes on the inner scale. So let's find, so 95 nautical miles an hour is right here. So we have 90 here, so 95 is right here. And then time, we want 45 minutes. So if we just find 45 here, remember this inner scale, so there's two scales. Let me go back to here. There's two scales. These numbers down here are hours, these ones are minutes. So if we look at the hours, there's nothing under an hour. There's no 0.75, so we can't use that scale, right? It starts at an hour and 10 minutes. So we want to use the minute scale and find 45. We want to line that up with 95, which we do right here, 95 on the outer scale. And now all we do is find the triangle and read off the outer scale above our triangle. That's, so 120 is here. Again, because 12 would not make sense as a ground speed, right? You got to use common sense here. So you add a 0, 120. So that makes this 125. And then we're 2 notches above that. So that's 127. All right. Another way you can do this is you're looking for ground speed. You have distance, you have time. So if you know this equation, just take 95 divided by the time. You just want to make sure that time is in terms of hours. So instead of 95 divided by 45, you'd want to do 95 divided by 0.75, because ground speed is in terms of nautical miles per hour, not nautical miles per minute. So we want to make sure this time is in hours, not minutes. All right, so that's that. So that's 2 of them. And now the last one here is, how long have you been flying with a ground speed of 100 knots and you've traveled 130 nautical miles? So here we have a ground speed and we have a distance, and now we need a time. So again, we have the ground speed, and we know that where this triangle is at all times, and we have a distance. Now we just need a time. So we have these 2 over here. So that means we can match the triangle with our ground speed, and then we just read off time underneath distance. All right, so let's do that. So we have ground speed of 100. Let's match 100 with our triangle. So here's our triangle. We match it with the 10. Remember, because the 10 for ground speed, that 10 means 100. And then now we've traveled 130 nautical miles. Distance is on the outer scale. It says it right here. You just refer to that. So we want to read underneath 130 nautical miles, the time. So we look for 130. So again, 130 is right here. It's the 13. And we look underneath that. So 80 is right here, 79, 76 it looks like. Or sorry, 79, 78. So 78 minutes, or if you kind of go down here another scale, it's about an hour, right? And 19 minutes, right? 79 minutes is an hour and 19 minutes. So does that make sense? Well, again, we can come here and we know ground speed, we know distance, we need to know time. You can rearrange this equation to say time equals distance over ground speed. And so distance is 130 divided by 100. That's 1.3 hours, 79 minutes. That's an hour and 19 minutes. That's pretty dang close to 1.3 hours, because 1.3 hours is an hour and 20 minutes, or an hour and 19 minutes actually. So it's almost exactly right. So use these equations to, I mean, these are very helpful. It's a tool to make sure you're not making these errors on these E6B. And then I know some of you guys use the electronic E6B, and I am just such a fan for so long of these paper ones. But one day I will make a tutorial on those. I'll dig up my electronic E6B and I'll do that. But if you can get that down, that also helps avoid these errors with this thing. But The reason I like this is because it never runs out of batteries. They're durable. They're, they're simple and they're old school. And I just like that old school feel of it. I like to know that I can do something. I always reference the zombie apocalypse where all power and electricity goes off. And we're stuck using our E6Bs and our magnetic compass. So I don't know. That's just me. But anyways, you're totally able to use the electronic E6B if you want. All right, cool. So no questions yet. That's a good sign. All right, let's get into these kind of red ones. These are going to be fuel. So the first one says, how much fuel have you burned with a 14 gallons per hour burn rate in 4.5 hours? So this is literally like the same. This should be T down here. All right. So this is really, if you think about it, this is the same equation. We have a rate. So a rate is something per time. So fuel consumption rate is just how much fuel you burn in a specific amount of time. Ground speed is how far you travel in a specific amount of time. And you can see that in the equation. It's fuel, the amount of fuel over time. And this is just distance over time. So it's the same exact concepts. And you can see that here. Keep erasing on top of my T. All right, and you can see that here, right? So again, we have the rate, the gallons per hour over the triangle. And then we have total gallons, like we had distance on the outer scale. And then time, again, is on the inner scale. That's why, right, we have the minutes and the hours on the inner. Let me check the chat real quick. Oh, yeah, my E6B is my original when I first flew. Yeah, these things last forever. Like, I think that's so cool. And yeah, with the 6-pack, I mean, there's a beauty to that. And it's like, I just did this when I recorded the podcast. I went over the lessons I made for how the instruments work. And I remember I was just totally geeking out on those lessons when I made them. And at the time I was like, is this too much information for students? And I kept telling myself, no, like if you understand how they work and how cool they are and how the simple machinery inside these instruments, like that can make you a better pilot when you understand what goes into these instruments and how they're giving you the reading that they are. Anyways, that's a tangent. But all right, let's get to this first example. How much fuel have you burned with a 14 gallon per hour burn rate? Let me erase some of the stuff. 14 gallon per hour burn rate in 4.5 hours. So we have the rate, we have gallons per hour, we obviously have our triangle, and we have a time. So again, we're going to match our triangle with our gallons per hour, 14, and then we have total gallons. We're going to read that off our time on the inner scale. So let's match our triangle up with 14 gallons per hour. All right, so here's our triangle. And now here, remember before when distance, this 14 would have been 140, right? Well, now it's 14. So again, just kind of use common sense. Your airplane is likely not going to be burning fuel at 140 gallons per hour. It's not a jet or the space shuttle. So just use common sense, and that'll help you with knowing whether this is 14 or 140. So we line that up with 14. Then we have, okay, 4.5 hours. Let's find 4.5 hours. Right here, 430. And then we read off like we did before with distance, but this time it's gallons on the outer scale. So if we come out here, so it's 60 here, and then 1, 2, 3. So 63 gallons. Again, ask yourself, always ask yourself, does that make sense? If you're burning 14 gallons per hour in 4.5 hours, does 63 make sense? To me, yes, it does. And if you want to use this handy dandy equation, right? So we want to know F. So we can rearrange this equation to put the T on the other side. So if we just do 14 times 4.5 hours, that's going to get us about 63 gallons. So again, always ask yourself, does this make sense? Is it logical when you're using these E6Bs? I also do that same thing when I'm using the performance charts and I get my answer, because you get lost in that chart, you know, your eyes are down and you're trying to line up these little lines, and you do like 5 different steps and then you come up with an answer. And if you don't kind of sit back and say, okay, does that actually make sense now? It's very helpful. All right, so that's that one. So 63 gallons. Next one, we're going to do, what is your fuel consumption rate if you have used 40 gallons in 3 hours? So now we want to know fuel consumption rate. We have fuel, 40 gallons. We have time. We have 3 hours. So we could just do 40 divided by 3, right? Use this equation. Or right here, we need this. We need the gallons per hour. We have our triangle. We have our total gallons. That's 40. And we have our time. So we just match up 40 over 3 hours, and then we read off gallons per hour over our triangle. So let's do that. So what is it? 40 over 3. So 40 is, sorry. See, I even got to check gallons on the outer scale. All right, so outer scale 40 and 3 hours times on the inner scale. So that's down here. 40 over 3 right here. 40 lined up with 3. We find the triangle. We read off here. Now again, I'm going to ask you guys this. Do you think this is 133 or is it 13.3? I'm going to wait for you guys' response. See if you're still awake in the chat. Remember what you're looking for. You're looking for fuel consumption rate. So does that mean we got 133 gallons per hour or 13.3 gallons per hour? What do you guys think? 13.3, says Fedor. See if anyone else has a guess. Roy says 13.3. All right, 13.3 is correct. You guys were using common sense, and you know that your aircraft probably burns between, anywhere from 9 gallons per hour to like 16 gallons per hour, something like that. That's sort of the range of your aircraft. It's not going to be burning 103 gallons per hour. That's crazy. You would go broke in a second training in that aircraft. All right, so 13.3, good job. Let's do one more of these fuel ones. Let me erase some of this red stuff. Okay. How long have you been flying if you have burned 35 gallons? Okay, so we have fuel at a fuel consumption rate of 10 gallons per hour. So we have the fuel consumption rate. So again, we have fuel consumption rate. We have the triangle. So we can line up fuel consumption rate over our triangle. And then we have the outer scale. We have the gallons, 35 gallons. So we can read the time off the inner scale. So let's do that. Let's line up the triangle with 10 gallons per hour. Here's our triangle. We line that up with 10 on the outer scale. And then we read off 35 gallons. We find that on the outer scale. So that's going to be down here. And it says 3.5 hours. So does that make sense? Let's see here. So we've burned 35 gallons and we have a fuel consumption rate of 10 gallons per hour. That sounds like it makes sense to me. If we want, we can use this little equation. We can solve for time. So we just have 35 divided by 10. That's going to equal 3.5 hours. So it makes sense. See what you guys said in the chat. 3.5 hours. Yep. Nice job, Fedor. Okay. All right. So that's fuel. Fuel consumption. It's just a rate. We did the ground speed. That's just a rate with distance and time. So now there's a couple more things that we can do with this E6B. And these are the ones in the blue. And I mentioned these before. So we have density altitude. So let's start with that. So, all right. So this question says, what's the density altitude when the temperature is 20 degrees C and the pressure altitude is 8,000 feet? So when you're taking the FAA written exam, you're going to have that density altitude chart in your figure book. It's got the pressure altitude table on the side, pressure altitude correction table on the side, and then it's got the density altitude chart. Now I would use the chart if I was on the FAA written. I wouldn't use my E6B. Again, we've talked about kind of the errors that can come about. And then as you'll see, this little window that we're going to use is kind of hard on the eyes. And just a tiny movement of your E6B, right? You could have it perfectly lined up and go to write something down on your piece of paper and move your thumb just a little bit, move it just a bit, and that's going to change your answer quite a bit. So I would use the chart and not your E6B on the written. But the E6B, when you are flying, is a great estimator of density altitude. And why do we care about density altitude? That's a good question for you guys. When you're flying, why is it a good thing to check for density altitude? Let's say we're flying into like a desert, a high desert place, like Sedona, Arizona, or something like that, and it's hot. It's like 90 degrees out, and we have short runway. Why would we care? Why would we want to check for the density altitude? Engine performance, airplane performance. Yep. Yeah, it's all performance. So you'll want to know kind of the density altitude limits of your aircraft. And so it's good to have a number in your head, like, okay, when the density altitude's above, I don't know, 8,000, 10,000, I would say even 8,000, then I got to start thinking about, okay, I got to redo my performance charts, and I got to, make sure I have the correct aircraft weight and really see how long is it going to take, what's the distance it's going to take me to land, what's the distance it's going to take me to lift off, am I going to be able to climb out over these mountains, stuff like that. So good job. So that's why it's handy to have the C6B. You can kind of say, all right, oh shoot, this density altitude is really high. Let's reconsider landing at this high airport, because the high density altitude means lower density, lower molecules of air. And so that's going to decrease the lifting performance. That's going to decrease the thrust performance of your propeller going through the wind, less air molecules to kind of thrust it forward. And then the engine performance, as Roy mentioned, there's less air molecules for the fuel to burn with. So the engine needs a propellant, which is your fuel, and an oxidizer, which is your air. It needs both of those. So when you start losing your oxidizer and you have too much fuel for your oxidizer, that ratio, that fuel to air ratio, is going to be disadvantageous. Is that a word? It's not going to be good. It's going to be bad. So you want that good fuel air mixture for good combustion. Anyways, let's do that. So that's a good reason why you want to use your E6B for these. But again, like I said, on the FAA written, I would use that chart because it'll be better to get when you want that exact answer and find that multiple choice answer. So how do we do this? All right, well, it says we have a temperature of 20 degrees Celsius and pressure altitude of 8,000 feet. So all we do, and it says here, it says pressure altitude in thousands of feet. And then right here, it says air temperature. So we have this little box. We have an air temperature scale, goes from 50 to minus 50. And you got to be careful. And that this is kind of swapped. You would think that minus would be to the left, but it's opposite. Plus is to the left and minus is to the right. So you got to be aware of that. So basically we just line up our temperature on this top scale with pressure altitude in here. And these numbers are in thousands of feet. Okay, so this 0 is 0, the 5 means 5,000, and every tick in between is 1,000 feet. And then when you spin, so let's see, get this back up here. As you can see, as we spin this, the window, you can see that the scale on the inside of the window changes. So let's zoom in. And again, this is why this tool is handy, because you can zoom in. And we want to find 20 degrees Celsius. We want to line that up with our pressure altitude of 8,000 feet. So we want to find the 8 notch inside here. So that's 3 after the 5. So 1, 2, 3. That's this notch right here. And then we want to line that up with plus 20 degrees. So 0 is here, 50 is here. So we have 10 and we have 20. So this one right here, we want to line that up with the 8. All right, so 0, 20. And if you stare at this long enough, you'll get dizzy and be hypnotized. So just, again, take a step back, take a breath, and really count it out. Okay, 6,000, 7,000, 8,000. That's lining up with this, which is 1, 2 notches away from the 0. So that's 20 is lined up with 8,000. So now we look here in this window, and we read off our density altitude where this little pointer points to. So this little pointer right here is pointing just above the 10. Again, this is in thousands of feet. So our density altitude is going to be, so this is in thousands of feet. And then each line is 1,000 feet. So this would be, this next line would be 11,000 feet. So this is like a fifth of the way. I would call that 10,200 feet for our density altitude. But if you're flying, I would just call that 10,000, right? You just need a good estimate. And that would be enough to tell me that in my Cessna or my Cherokee Warrior, I need to start thinking about performance on my landing or my takeoff or my climb out. So definitely, I mean, if, like I said, if this is above 6,000, 7,000, I would start thinking it. And as you're, before you get to know your aircraft, I would do that every time. Like, let's all be safe all the time. But just saying, once you get to know your aircraft, you kind of know that number of when you got to start worrying about that. And also the weight is included into that performance for takeoff and landing. So, but always do it until you get a good grasp of your aircraft. 10,500 feet on my paper E6B. Yeah, so see, that's kind of the air fedora that I'm talking about. And that's why if you're asked what's the density altitude on the FAA written, I would use that chart, that paper chart, not this E6B or not your paper E6B. What I mean is, let me pull up that chart so you guys know what I'm talking about. All right, this chart right here. So let's just do it on this chart. So we have 20 degrees. So we want to find 20 degrees Celsius on this scale down here. That's going to be about right here. And then we want to draw a line straight up until we reach the 8,000 line. That's going to be this 8,000 line, this one that goes horizontal here. And then we draw a line at the intersection over to here. And then we read off density altitude here. And that's going to be about 10,200, it looks like, on this one. So again, it's easy to make a small little mistake. Like if I didn't have this perfectly lined up, like let's just show you. All right, so I had, so 20 degrees is right here, and right now it's perfectly lined up on the 8. But if I had it, let's say I just lined it up with the 25-degree line instead. I made that goof. I put the 25-degree line on 8,000. Just doing that changed it to 10,000, 11,000 feet. So just that small change, that little like millimeter of change in spinning this thing, changed that a whole bunch. So again, it's great for estimations when you're flying. But I would use this chart when doing FAA written questions. Does that make sense? Uh-oh. Oh, there we go. Thought I lost everything for a second. Okay, let's get rid of this. All right, we got one more example. So this is, you're gonna use this when you're doing cross-country flight planning. And the way I teach it is to do it for climb. So for all your checkpoints, you're between each checkpoint. Let me see what the chat is, see if there's a question before I get started with this. Okay, no question. All right, cool. So every checkpoint, you're going to need a true airspeed, and then you use the wind side of the E6B, which we'll get to next week. Wind side of the E6B here. To go from true airspeed to ground speed, because you want that ground speed. Ground speed, again, tells us distance, time, and we want that distance and time in our heads, because we want to know, be able to use piloted and dead reckoning to know based off how long we've been flying, where we are on our map, things like that. So that's why we need ground speed for every checkpoint. And to get there, we need true airspeed. When you climb out, this is why I teach it this way. When you climb out, what do you usually target? You usually target an indicated airspeed, right? Usually target like VY or VX. So a Cherokee Warrior VY is 79 knots. So you're not targeting like a power setting or something like that on takeoff. You're trimming for that best climb speed, right? So you're trimming for 79. So you have, that's an indicated airspeed. That's what you're looking. You're hitting 79 right on your airspeed indicator. That's indicated. So you know an indicated airspeed. So for the climb out, I like to start with indicated airspeed and then use my E6B, again, because we need true airspeed for every single point to get ground speed for every single point. So that's just a very simple way. So I put for my climb out checkpoints, every checkpoint that I'm climbing, I put my best climb speed, 79. And then depending on the conditions, I calculate the true airspeed with my flight computer, my E6B, which we're going to do now. Okay. So let's say we were climbing 110 knots, like in this, it says true, what's your true airspeed? If your indicated airspeed is 110 knots and you're flying at 5,000 pressure altitude, 5,000 feet pressure altitude, where the temperature is 10 degrees Celsius. All right. So let's say we're climbing, we're at a little bit more high performance aircraft so that we can climb at a higher speed. And that best climb speed, let's say that is 110 knots. And so we're climbing out and we want to know at a certain checkpoint, we're at 5,000 feet. We want to know, okay, what about our true airspeed at that point? We know that the temperature from our winds aloft is 10 degrees Celsius. So with that information, we can use our E6B to find our true airspeed. And it tells us how to do this right here. So it says set pressure altitude. Let me zoom in here for you guys. It says set pressure altitude opposite degrees Celsius in the window. So again, this window here. And then opposite CAS, that's calibrated airspeed on inner scale. So again, inner scale is the gray that we are using for time. Read off true airspeed, TAS, true airspeed on outer scale, and then read density altitude off here, just like we did before. All right, so what is CAS? Calibrated airspeed is indicated airspeed corrected for instrumentation errors in your aircraft. For general aviation training aircraft, the instrumentation errors are very small. It's like 1 to 2%. So all across the United States, they teach that students that indicated airspeed is the same as calibrated airspeed. So just take this as calibrated airspeed. And if you're on your check ride, this could be total. I could totally see an examiner saying, all right, that says calibrated airspeed. Why are you using indicated airspeed? So you're going to have to know what I just said, basically, that with the speeds that we're flying at in our general aviation aircraft, the air from indicated airspeed to calibrated airspeed is so low that we can assume those things that are the same. But if you wanted to know the change, there is a chart to convert from indicated airspeed to calibrated airspeed and to fix those errors in your POH or AFM for your aircraft, the pilot operating handbook of your aircraft. It tells you that air for whatever indicated airspeed, what the correlating calibrated airspeed will be for your aircraft. So if you really want to do that, you could use the POH. But like I said, the air is so small at our speeds that we just say that that's the same. All right, so that's spiel. It's good to know, again, because I could totally see an examiner asking that. All right, but let's get to it. So let's put, just like we did before, let's match our 5,000 pressure altitude with 10 degrees Celsius. So we're gonna come back here. All right, we have 5,000 feet, so we're looking at the 5. And we want to match that with 10 degrees Celsius. So that's the first notch right here. Match that up with our 5. Do the best we can to line it up, right? That's lined up. And then now if we zoom out just a little bit, what does it say? It says opposite calibrated airspeed on inner scale, or remember, calibrated airspeed is our indicated airspeed on inner scale. Read true airspeed on outer scale. So we want to find on this scale our calibrated airspeed or indicated airspeed, which is 110 knots. And then we will read off our true airspeed. So we want to use what we were using before as the minutes. So this scale here, we want to find 110. So remember, it doesn't go above 100, these numbers, but it does do 10. So that means 100, you add a 0. So the 11 is 110. So we just read off this outer scale above 110. And it's almost lined up on the 120. So I would call that 120. So we have a true airspeed of 119.5 or 120 knots true airspeed. That is the same exact procedure as we were doing to find our density altitude. Just line up our pressure altitude and our temperature, and then read off indicate out airspeed. Sorry, read off true airspeed over indicated airspeed, because again, true indicated airspeed is the same as calibrated airspeed. All righty. So any questions? That's all the examples I wanted to get through. I know it was a lot, and it was tedious, and a lot of them were the same, but I wanted to make sure that we were all clear on, hopefully it makes more sense what this computer is doing. It's basically just doing 3 different equations, this, and then our pressure altitude and density altitude conversions with indicated and true airspeed tied into that. It's a really, like, I don't know who thought this up, but it's really smart tool. Again, I'm a geek for these things. But all right, let me know if you guys have any questions on this or anything else. We have about 8 more minutes. So sorry we didn't have more time for your questions, but any other questions? Yeah, Mike, Fedor, no problem, guys. Glad it makes sense. So yeah, I'll give you some time. I'm here for the next 8 minutes. Think of any question you guys might have for me. Even if you just want to chat about something, I don't know. What do you guys think about next week doing the wind side? Did you think that was helpful? Would be doing the wind side of the E6B be helpful next week? Mike says yes. Okay. Yes. All right, cool. Yeah, we'll do that next week. We will definitely do that next week. That one's I think that it's easier because I mean, it just straight up tells you the step by step, you know, right here. Where it gets tricky is the FAA written will they'll ask you some tricky things where you kind of got to work backwards with this thing. So it's good to understand how this works. And maybe I think we've done one. Maybe I'll grab probably like one of those tricky FAA questions that we can do. All right, no questions. Thank you guys for joining. Oh, Fedor says, what else is allowed on the FAA written besides an E6B? A very, very standard calculator. Basically, you can have your electronic E6B and you can have a calculator, but they're going to check it. It can have no computing power. It can have no connection to the internet. So it can't be, you know, smartphone or anything like that. And that's another reason I just didn't want to mess with that. I was like, okay, I'll just bring in my paper E6B. It's got all these equations on it, all these helpful things that I might need on other questions on the exam. So your E6B, a basic calculator. What I did is because I was like, I have from my school as an aerospace engineer, I have like this scientific computing calculator. That was the only calculator I had. I usually use my phone as a calculator. So I was like, crap, I don't think I could bring this calculator. So I just called them, asked them if they have calculators that they lend out, and they do. And I think on some of these, the computer program, actually you can pop up a little simple calculator. And then Fedor, to finish your question, they will provide you the FAA figures booklet. So that was like the density altitude chart that was one of them. So they'll provide you all the figures. So whenever the question says refer to figure 40, they'll provide you that little booklet. And then they'll have pencils and scratch paper that you can use. So just bring your E6B and a simple calculator and just let them, they'll probably want to check it to make sure. Roy says, can you have one of those that print up the history? I'm not sure what you mean, Roy. History of your, like it tells you, it keeps a running total of what, a history of what. I'm gonna go with no on that. When I say like the simple calculators, I mean just the simple calculators. And I said to call the testing site. That's the best way. Oh, like the receipt paper. I don't know about that. That's a call the testing center and ask them. But I'm gonna say no. They probably won't let you. But the best way again is to call and then have backup plans, right? Yeah, I know it's not a smart calculator, but they might think you're on that roll of paper inside there that you got answers written on it or something. You know, they provide you with that scratch paper. They don't want you bringing in notes or anything like that. So but people get really smart about how to cheat. I would never. I never have done that ever. But yeah, so best thing to do is call the testing center. And if you're unsure, have a backup plan. Be like, hey, I brought this calculator, but if this isn't allowed, here's this really simple one that I also got. So, all right, guys. Well, if there's no more questions, I will chat with you guys next week. We'll do the wind side of E6B. And then if you want to watch this recording, I'll send out the email. It'll be in your bonus courses sometime this week. That's the bonus online ground school downloads and video vault. And then it'll also be on YouTube for about a week. I let the non-members watch it for about a week before I take it away and say, you got to join the school. Anyways. Keith, halfway through. Nice job. Awesome, man. Thank you, Mike. Thanks for joining. Thanks, Fedor. No problem, man. Good job, guys. Proud of you. See you next week.